I'm gonna do the best I can to kind of go through this quiz review. We should be doing like a Microsoft Teams meeting the day we're gonna be working through this, but I wanna put the video up ahead of time and maybe see if you get some questions. Again, we gotta go back through graphing exponentials. We just kind of finished up with logs. I know this is gonna be difficult for some of you guys, but I'm very confident if you put the time in, and it's gonna take some time. You're at home all day. You should be at home all day. So you should be able to look through some of these things, talk to some other people, and do the best you can. We're not gonna overly crush you with these assessments, but we're gonna be checking for understanding, if you will. Okay, so this is an exponential function, unlike the other one. So exponential function basically starts like this when we start talking about growth, or like this when we start talking about decay. And then we'll talking about reflections and things like that. That's the hard part sometimes is they look very similar. The difference between understanding their exponential and not logarithmic, especially for this one, is it doesn't have a vertical asymptote. It has a horizontal. So all exponentials will have horizontal asymptotes. That's a key understanding. So for this, obviously this is growth. This being decay. Has this been reflected? No. Where's my horizontal asymptote? Y equals -3, because each one of those points, Y, this is Y equals -3. This is decay, going from left to right, going down. Has it been reflected? No. Horizontal asymptote, Y equals -3. We look over to this one. If we took this one and flipped it basically over an x-axis or from top to bottom, this is still a growth function. It has been reflected. And our horizontal asymptote is at y equals 5. Again, this line, for each point on that line, y equals 5. So for instance, this point here is at -1, 5. This point here is at -5, 5. And you'll see each one of those is y equal to 5. X changes, but y stays the same. This one here is a decay function. It has been reflected. And my horizontal asymptote is at y equal to 3. Again, this point here, 4, 3. This point here, 1, 3. This point here, -4, 3. They all are y equal to 3. That's why those asymptotes are like that. Cool? All right, so let's roll down. Let's do an example. I do these a little bit differently than I do the logarithms, because these I can plug in values for, if you will. Okay? So our baseline function is always going to be y equal, or f of x, whatever you want to call it, a, b, x minus h plus k. That's our baseline function. So if we look in those terms, our b, unlike the other one with the logarithms, really has a play in all of this. So our b is 3. Our a is 4. Our h is x minus h. That means that this would have to be x minus -2. So our h is -2. And our k is -1. Transformations, okay? Well, let's talk about this. This determines growth or decay. Greater than 1, b is greater than 1, which means it will be growth. Not going to deal with the point just yet. We'll talk about that in a minute. Our horizontal asymptote will always be this baseline. of y equal to 0, this dictates it goes down 1. So we have a down 1. That means our horizontal asymptote is going to go down 1 to y equals -1. Now the point is a little bit of a challenge here. I'm going to erase a little bit of this so we still see the real problem. The point is a little bit of a challenge here because our baseline point is always 0, 1. When you're trying to find your baseline point again, you're always trying to make that right there 0. Okay? You want that to be zeros because if I raise 3 to the 0, it's simply 1. Then I can find where my baseline point is going to be. Unlike the other one where we're sliding left, right, we're doing all these types of things. Even though these are transformations we're going to talk about, for exponentials, because it's not a logarithm, you can plug this value into a calculator or whatever and figure out where your points are going to be. So if I make x -2, that means I would have y equal to 4 times 3 to -2 plus 2 minus 1. If I made y equal to -3, okay? X equal to -2. Then I'm going to have y equal to 4 raised to the 3 raised to the 0 minus 1, which is y equals 4 times 1 minus 1, which is y equals 4 minus 1, which is y equal to 3. So our baseline point now, instead of it being 1, 0, is going to be at -2, 3. And if we can follow that kind of understanding, we'll again be able to figure out what this thing's going to look like. Again, it is growth. So growth is going to look like this. You can then, for this, plug in a bunch of values that will give you, again, a bunch of different things. But at the end of the day, if you find out your horizontal asymptote, understand your baseline point, you're going to know it's going to look like this. I know I'm somewhat minimizing it, but at the same time, we need you to at least be able to do this type of understanding. This here, this 4 vertically stretches by 4. So that's a transformation. Vertical stretch by factor of 4. That means everything's getting multiplied by 4. We could have done all these other points the same way. Had you moved this, and it would have still ended up with your baseline point of -2 to the 3. But I think it's easiest to go that way with it. Okay? Plug in what's going to make that 0, and that's going to give you a baseline point. This also moves it left or right. Since it's negative, this is negative, this is positive, it's going to go left 2. If we think about it, domain and range, domain is from left to right. This thing doesn't stop. Negative infinity to infinity. Our range goes from bottom to top. So it's going to go from -1, which is where our asymptote is, up into infinity. And from left to right, increasing or decreasing, it is increasing. And that's the baseline understanding of how to do these. You're going to have to remember certain things. Again, you're going to be at home, so you should be able to use your notes on all of these things. If you're taking notes, if you're applying yourself, you will be fine. Let's go to the next problem. A little bit different here. But again, when you're dealing with these fractions, This is where things get a little bit hectic and you're like, well, where is my baseline point? What am I doing? But if you follow the same pattern for the whole thing, you will be fine. You should have ability to be fine. Here, A is 3. This is my A. This is my B is 1/2. This is a decay because my B is less than 1. Greater than 0, but less than 1. My H, this is X minus H, so my H is simply 2, and my K is -3. This is plus K, so it'd be plus or negative plus -3, if you would. Okay? So, here, vertical stretch by 3, decay, positive, right 2, down 3. So I have a decay, not quite sure on what my point's going to be. I have my transformations, vertical stretch by 3. I have my H, which means it's right 2. And I have my K, which is down 3. The K is going to dictate, again, your horizontal asymptote, which starts at x equal to 0, and is going to go down 3. Excuse me, y equal to 0, apologies. Y equals -3. So that's my horizontal asymptote. And at that point, you hopefully can memorize that it's exponential, so my negative infinity to infinity is going to hold true. And then this one will be from my negative, since it did get flipped, -3 to infinity. I don't know my point just yet, but let's deal with that. Let's go back and find out what I can do. So now I have, let me use a different color so it pops. Y equal to 3 to the 1/2 of x minus 2 minus 3. Well, again, what should I plug in there? If I plugged in 2 there, y equals 3 to the 1/2 of 2 minus 2 minus 3. That gives me y equals 3 to the 1/2 of 0 minus 3. Anything raised to the 0 is 1. 3 to the 1 minus 3. Y equals 3 minus 3. Y equals 0. So when my x is 2, my y is 0. X is 2. My y is 0. And there's your baseline point. It is a decay function. Decay meaning it's going to be going from left to right. So at the end of the day, this thing is going to look like this. Even if you don't have multiple points plugged in, you should be able to get to that understanding of where we're at. Okay? So we're looking at this. This is our decay. It is from left to right, decreasing. You should be able to identify these, manipulate this exponent to be 0 to find your baseline point, and then roll from there. All right, let's do one that's all flip-flopped and all over the place, because this is going to make a difference. Again, keeping this stuff straight sometimes is difficult, but it takes practice. You guys are at home all day. You have plenty of time to practice. Hey, all right. Looking here, A is at -2. That means it's vertically stretched by 2, and it's reflected over x-axis. Vertically stretched by 2, reflect x-axis. Got those two. I'm doing this each a little bit differently just to kind of give you a different feel for how you can break this down. Our B is 4. So it means it's going to be a growth. Our h is x minus -1, which would give me that plus. So our h is -1, which means it's going to go left 1. Remember, negative, positive, left 1. And our k is 2, so it will be going up 2. Horizontal asymptote starts at y equal to 0. Up 2 means now it is at y equal to 2. Our domain is going to be consistent. So let's just roll with that. So now let's do our point. Okay? So if our point is at -2, 4, and I'm just going to x minus, so I'm going to do 1 plus 2. Y equals. So when x is -1, when x is -1, y, -2 times 4 to 0 plus 2 equals -2 times 1 plus 2 equals -2 plus 2 equals 0. So we have a point that will be at -1, 0. That's our point. Okay, so this is a growth function. So the growth function typically looks like this, right? That's a growth function. However, it's been flipped or reflected. So now it's going to look like that. So now you have a point that's going to look like that. It's going to be under it because it's been reflected over this asymptote, if you will. Instead of being on top of it, going up, it's on the bottom of it. So now we can read our increase, decrease from left to right. It is decreasing. And our range is going from -infinity up until it hits that asymptote of +2. Again, it takes some practice, but these are still all the same little steps that you would do to do all of these. These would be the same way I'd be explaining it in class. Again, I'll put this video up. Hopefully, you'll be able to understand a little bit more. So even though we did do logarithms already, we're going to, I'm trying to get this other log problem off the screen. There we go. Again, attacking these problems a little bit differently, at least I do. Everybody has their approach to everything, but I think this makes the most sense because I don't know how to plug in all numbers into here. Log of base, I don't want to plug in numbers to that. I can't deal with that kind of stuff. But I can move things. I can understand my baseline, which now my baseline is at x equals 0 and 1, 0. It's my baseline for logarithms. Okay? So we have to determine what it's going to look like. Is it positive? Is it negative? Increase, decrease, and so forth. Here's a 1 out front, so it's 1. So right off the rip, it's positive. Okay? Our baseline, our base is log base of 3. That's hard. That's a challenging one, but it really doesn't matter when we're dealing with these right now. This is x minus -9, because that'd be negative is a positive. So our h is at -9. And our k is at -1. So now we don't have any reflection. We don't have any vertical stretch or anything like that. But this is going left 9 and down 1. So left 9, down 1. So our point, all these things, asymptote, left 9. Now it's at x equals negative 9. Went from x equals 0, left 9. Now this point goes left 9. So if I moved it left 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, I'm going to be at negative 8, right? But then I also have to go down 1, so I'm at negative 1. So now my point is at negative 8, negative 1. At this understanding, we have to determine what does a logarithm graph look like. Our logarithm graphs always look like this. So we're just going like this. It hasn't been changed. We're not looking for over the top. Can you understand the baseline of that? That's my expectations for you. So my domain is going to go from left to right, which is at negative 9 to infinity. My range is going from bottom to top, which is at negative infinity to infinity. Again, remember that flip-flop, the x, y? Our domain for our exponentials was all real. Now our range is all real because this now is from x to the y. Not a difficult problem, but if you start trying to plug in numbers here, you're going to have a problem. If you try to do this the same way as the if you try to do these the same way, you're going to have problems based on the fact that you're going to have this magnifier that you got to deal with over here. It's better just to move that point originally or plug in and make that that x value to make it that exponent 0. Again, a little bit different approach to how you do each one, but that's the difference why this is logarithms versus exponentials. It has some to do in common, but not everything. Let's do one more. Hopefully this video is not overly crazy, and you might prefer this over looking at my hand on a piece of wood. Alright, so 1, A is 1, is still positive. So it's still positive. It hasn't been reflected, which means it's going to look like that. Before we even do anything, baseline understanding. 4 doesn't really matter. X minus negative 4, because that gives me my plus. So H is negative 4, and my K is negative 5. So now I have no vertical stretch, no reflection, but I do have left 4. I do have down 5. So if I go back to my original points and stuff, x equals 0, 1, 0. And this is going to help a lot of you guys. It will. You'll be lazy and won't do it, but it'll help you. Left 4 means I'm going to take this thing to x equals negative 4. So now that's my vertical asymptote. And negative 4. Let me get a different color in here. 1, 2, 4. That is at negative 3. And then I have to go down 5. 1, 2, 3, 4, 5. So now I'm at negative 3, negative 5. Don't start to try to plug in a bunch of different numbers with this. Just don't do it. It's not worth it right now. Positive, shape hasn't changed. Looks like this of some sort. Doesn't have to be perfect. Our domain goes from negative 4 to infinity. Our range goes from infinity to infinity. Again, our negative 4 is our x value there. And from left to right, it is increasing. I hope you enjoyed this video and stay safe. Hopefully I'll see you guys next year.